These days, news of the opioid crisis is everywhere. This epidemic takes more lives than car crashes and is the #1 leading cause of death in Americans under 50. We're working towards solutions to this problem, and I'm going to tell you how we're doing it. But first, I want to tell you a little bit about opioids. They're great for pain. You might have even experienced this yourself, like I did. A couple years ago, I got my wisdom teeth pulled out, and I was in a lot of pain as seen by this embarrassing picture. Plus, I was moody, agitated, and that's not my normal personality. It was the pain that made me feel this way. But after taking my prescribed opioid pill, I felt great, as seen by this even more embarrassing picture. Finally, I could sleep, eat, and I didn't mind the pain. But importantly, I could still feel other types of pain, like the painfully hot temperature of the tea I was drinking. That's because opioids don't work by blocking our physical ability to feel pain. They work by blocking our negative feelings and emotions that we have because of the pain. So on one hand, they're excellent for pain relief because they bind to regions of our brain important for feelings and emotions. But on the other hand, they can be highly addictive and have deadly side effects. So it's very important that we understand exactly how they provide the pain relief part so we can develop medications that work as well as opioids do but don't have the harmful side effects. I wanted to know which specific region of the brain was important for the good feelings associated with pain relief from opioids, and I did this preclinical study in rats. Now, a rat can't talk or tell us how it feels on a medication like a human could, so we had to get creative. First, we gave rats a nerve injury that mimics a human chronic pain condition. Then, we injected an opioid into our region of interest in the brain. Next, we placed the rat into one of 2 rooms, and I'll call this the pain relief room. And we confined the rat to this room for a period of time so it's able to associate pain relief with the context of the room. The next day, we allow the rat to choose on its own which room it prefers to go into. The idea is, if the rat actually had pain relief from the opioid injection into the specific site that we were interested in and felt good, like I did when I got the pill for my teeth, then it'll go right back into the pain relief room and stay there, hoping to get more of that opioid. If it didn't get any pain relief, then it wouldn't care and it would simply explore both rooms equally. We were able to find one particular site within the rat's prefrontal cortex that is especially important for the good feelings associated with pain relief from opioids. Now, why is this important? Well, because for several decades now, scientists have been trying unsuccessfully to uncouple pain relief from addiction. Now, by targeting the neurons in this specific site, we can actually finally do that. Understanding pain signaling in the brain is what will lead to the development of medications that are still highly effective but non-addictive. And ultimately, it will be these novel pain therapies that will contribute to the end of the opioid crisis. Thank you.